welcome to Waidsum Academy. Today we are looking at chapter 19, Mathematics, IGCSE Mathematics Chapter 19, Differentiation and Gradient Function. This chapter can serve for both mathematics and additional mathematics. So without much ado, let's begin. Okay, now let's start with, we say calculus is the cornerstone of much of the mathematics that we study in higher level. The mathematics we do in the university, in colleges, is usually calculus. Okay, calculus includes differentiation, integrations. Okay, differentiation and integration is mainly calculus. So the mathematics you'll be doing in the foundation, if you are in science stream, the mathematics you do in science stream in foundation is calculus. The mathematics you study in the foundation is calculus. So calculus involves differentiation and integration. Now, a differential calculus deals with the finding the gradient of a function, okay? Finding the gradient of a function, while the integral calculus deals with the area of surfaces of objects, okay? So these are the two varied applications of mathematics that we call calculus. Now let's start with gradient. We've learned gradient before in earlier chapters, or even in earlier chapters or lower grades. So gradient is the change in y-axis over change in x-axis of a straight line graph. It's change in the y-axis over change in x-axis. So when we give you a line, if we want to calculate the gradient, we have to identify 2 points on the straight line. We have to identify 2 points, point A and point B, or point P and point Q. Okay, so you know every point in a geometry, in a coordinate geometry, every point has a coordinate. So this point P, has a coordinate of 1,5, and point Q has a coordinate of 11,10. So to calculate the gradient, you know, we can use broken lines to make it a triangle. Okay, make a triangle of these 2 points so that you know that you want to find the change in y, which is this change, the vertical change, which is y2 minus y1. Here is x2, comma, this place is x2, comma, x1. Sorry, x2, comma, y2 is x2, comma, y2, this coordinate point, the higher point. The lower point is x1, comma, y1. x1, comma, y1. This is the lower one, this lower one. Okay, now to find gradient is m. Gradient m is the change in y, that's the change in the vertical orientation, the change in the vertical orientation of the vertical distance of these 2 points, that's the meaning. The vertical distance of these 2 points, which is y2 minus y1. So here is called y2, meaning the up value of the y point of this coordinate point, and the lower part of this one, the y of this one. So we say the vertical orientation is the change in the y-axis, which is y2 minus y1. Okay, so that's what we write for gradient, y2 minus y1 over the change in the horizontal axis, over the change in the horizontal axis. What's the change in the horizontal axis? The horizontal axis is this one. Okay, the x2, you trace this one to the x2, this one. This is the x value of the higher point, minus the x value of the lower point. So we say over x2 minus x1. So this is how we calculate gradient. I think in lower grade we've studied formula for calculating gradient. So gradient is like differentiation or rate of change. We say 10 minus 5 for the y value, because this is y2, y1, and this is y2, 10. So we say 10 minus 5. We say 10 minus 5, which is the y2 minus y1 over, now x2 is what? 11, and x1 is 1. So we say over 11 minus 1, which is 10. So we get 5 over 10. 5 over 10 equals to 1 over 2, if you simplify to the rest term. So that's the gradient, meaning half. The gradient of this graph means A, and then we calculate the gradient of that point. Now let's move on. Now here we'll be looking at 1 plus h, which is x2, and 1 plus h squared, which is y2, and here is 1 and 1. x1 is 1, y1 is 1. So we will substitute into the gradient formula. y2 is 1 plus h, both of them squared, minus y1, which is 1, y1 is 1, okay, over over, what's our x2? 1 plus h. So our s2 is 1 plus h over 1 plus h minus x1, which is 1, minus x1, which is 1, h at the bottom. So this one simplifies down to h to 2 plus h over h. So this h outside down here, we cancel the h here. So the gradient will be 2 plus h. The gradient will be 2 plus h. The gradient will be 2 plus h. So it's easy, no matter what. It's the same gradient formula we follow. We just substitute the coordinate values into the gradient formula. Is that okay? So let's move on. You can pause the video and try some of these questions. Okay. Now let's take a look at gradient of a function. As we said, it's the same as differentiation. Okay, the gradient, which is like f of x, the gradient of a function is the same as the rate of change and is the same as differentiation. Can be written as f prime of x, or what we call dy over dx. The gradient of a function is same as, because you are saying change in y over change in x. That y2 minus y1 can be denoted as dy, and x2 minus x1 will be denoted as dx. So the gradient is same as rate of change, and or is same as differentiation, same as differentiation, because differentiation is simply to find the change in the y over change in the x. For example, if I give you y equals to x squared, like a graph, a quadratic graph, y equals to x squared. If I say differentiate it, if we say differentiate this one, if we say differentiate this one, it means I will say dy over dx. It means you are finding the change in the y over change in the x. So if I say differentiate, means you are going to find the gradient, dy over, bring it to the back as the coefficient. Take this power 2. So instead of, you bring the 2 to the to be a coefficient of x. So you write 2x. Instead of x squared, you write 2x. You bring the 2. Then the power will be minus 1. 2 minus 1. 2 minus 1. In the power, we say 2 minus 1, which means if we have, eventually this one will become 2x. This one will be equal to 2x, because 2 minus 1 is what? 1. 2 minus 1 is equal to 1, so same as 2x. Okay, so this is what it reduces to. In a nutshell, what it means is that if you are asked to differentiate, let's say y equals to, say dy in a simple way, in a very simple way. We say dy, that means change in the y over change in x. Change in y over change in x is simply equal to bringing this power to multiply whatever is here. This one already has a coefficient, let's say 4. Let's say a is 4. Okay, so you say a times 4, a times n, a times this power, y times, I'll use dot as multiplication, a times n, which is an. Then before you write x raised to power for differentiating. This is the technique for writing differentiation. When we are given a function, this is what we do. When we are given a function, this is what we do. This is how we differentiate. We bring the power to multiply the coefficient, and we subtract 1 from the power. This is how we differentiate. Okay, we're going to look at differentiation from first principle, but this is how we differentiate. It's easy, very easy thing to do. Now you hear differentiation from first principle. Differentiation from first principle, I'm going to do it in a simpler way than the way this textbook did it, okay? The textbook did, it has a coordinate point here, and then substitute it to the gradient function, and then he arrived at the function which we call first principle. But however, let me show it in a classical way, in an easy way, and that is less confusing than what the textbook did. But we look at what the textbook did, and we see. If you want to differentiate from first principle, this is what you do. They give you y equal to s squared, right? If you give you y equal to s squared, what do? You say you add to the left a small increment. You say plus dy, y plus dy. So you should do this differentiate from first principle. Only in rare cases they ask you in the exam to differentiate from first principle. They will just ask you to differentiate. Okay, then you do the short way. But if they say differentiate from first principle, we have to follow this way. Now, you say y plus small increment in y plus small increment in y is equals to x plus small increment in x. Remember this one is square, so you have to square both of this. That's step one. Step two is that we have to expand this one. So I write this one the way it is, y plus dy equal to, you see this dy is not like the normal d from this one. It's different from this one. This one is standing properly as a d, right? But because it's real, that one is the real differentiation. This one is just a small increment. This d in this way is a small increment. So you say y plus dy equals to x plus dx. Now if you expand this one, you get s squared plus 2s ds plus ds squared. This is what you get. You can do this by writing s plus ds in one bracket, s plus ds in another bracket. You expand, you get this one. It's easy as that. You get this one, s squared plus 2s dx plus the ds squared. So that's it. Then the next stage, I want to subtract the value of y from both sides. I'll say this left side minus y. I'll put minus y here. So that the y plus y and minus y will cancel, only dy will remain on the left. So that's what I wrote here. I said subtract value of y from both sides. That's what I wrote here. Meaning subtract y from here. The value of y on the left is y. The value of y on the right is s squared. Because you say y equal to s squared, right? On this side, instead of saying minus y, you say minus s squared. Because that's the equivalent value of y on the right side. So you say minus s squared. So if I minus s squared, if I put minus s squared here, if I subtract s squared, what it means is that if I put minus s squared here, what it means is that this s squared and this s squared, they will cancel out. Plus s squared minus s squared, they will cancel out. So what remains is 2s ds plus ds squared. Okay, that's what will remain. 2s ds plus ds squared. So I've removed the y from the left. I've removed the y value from the right. Y value is s squared on the right. So I subtract. So what is left is this. Then the next thing to do is to divide both sides by dx. The small increment, not the proper dx. The small increment. So I divide the left side by ds. I divide the right side by ds. So I divide here dy over ds equal to this ds divided by dx. And then ds squared divided by ds. This ds squared, it means ds and ds, two ds and ds. So one of them will cancel the one at the bottom, remaining one. Okay, then here this ds will cancel this ds, remaining only 2x. So what we have now is dy over ds equals to 2x plus dx. dy over ds equals to 2x plus dx. Okay, as limit ds are points on the gradient are coming close to each other. When the 2 points are coming close to each other, the ds will be approaching 0. That small increment will be tending to 0. The small increment, when this point P and point Q are getting closer to each other, you bring them close to each other, that small increment dx will approach 0 in maths, in limit, in calculus. That's what we say. That's what we do. So ds is approaching 0 as limit. ds is as the 2 points on the gradient, on the curve, they are coming close to each other. We say limit ds approaches 0. So when limit ds approaches 0, this one will become 0, or approach 0. So what is remaining? Then this one, once limit ds approaches 0, this one will become the proper d. To solve it, ordinarily, that's what you're supposed to get, right? 2x equals to 2x. This was the question. Remember, the original question is y equals to x squared. The original question was y equals to x squared. When you do differentiation from first principle, it takes you a bit longer. But if you just do normal differentiation, if I say differentiate this one, you just say dy over dx. You just say dy over dx. dy over dx. dy over dx is equals to, like I said before, this one will be equal to, dy over dx, university, you bring this 3 here, it becomes 3 times 2, you get 6. Then x raised to power 3 minus 1. 3 minus 1 is 2, so x raised to power 2. Finish, you've differentiated this one. It's so easy game, right? So that's how they got 6x squared. See, they got 6x squared. Similarly, if you're given this function, calculate the function y equals to, calculate the gradient function y equals to 5x raised to power 4. So you just say dy over ds. You must do dy, you must write this dy over ds is equals to, you bring this 4 to multiply this 5. You bring the power to the coefficient side. 4 times 5, 20. So you have 20. Then you say 4 minus 1, which is 3. So you say 20x to the power of 3. That's how they got this one, 20x to the power of 3. So at this point, you pause the video and solve all of this. Now they want to introduce differentiation proper. They've just shown you the gradient function, and they've told you gradient function is a differentiation. Now, what is differentiation? Differentiation is the process of finding the gradient function. Okay, the process of finding the gradient function is known as a differentiation. The process of finding the gradient function is also known as a differentiation. Differentiating a function produces a derivative. You can do first and second derivative. Okay, like the question just now, you can do first derivative, which is dy over dx. Second derivative is d square y. If I want to do second derivative, there's third derivative, meaning differentiate the answer again. That's the meaning. The first time you differentiate is the first derivative, which is this one. Differentiate the answer again. Differentiate. So this time you don't call it, you say d square y, because you are doing it second time. D square y over dx squared. Okay? You say d square y over dx squared. This is how we write it. We don't say dy squared over dx squared. We say d square y over dx squared. So this is the second derivative, meaning differentiate this one. If I do, I will now have 12. Third derivative is the cube y over ds cube of the same function, okay, of the s cube. If you are doing the third derivatives, this will be equal to, meaning differentiate the answer you got for the second one. So this will be equal to, you know, there's 1 here in the power. 1 times 12 will be 12. And then 1 minus 1, you know, in the power, you say 1 minus 1, that's 0. S raised to power 0 is 1. 1 times 12 is 12. So if you do a third derivative, the answer will just be 12. The answer will just be 12. So we can have first derivative, second derivative, third derivative. Okay? So differentiation is just to, but however, if you have a straight line, vertical line like this, differentiation will be 0. Differentiation will be 0. That's a constant. That's why if you differentiate a constant, the answer will be 0. Differentiation is rate of change. It must be a slope before you can differentiate. Okay? Okay, so when you differentiate a constant like 3, the answer will be 0. If you differentiate 100, the answer will be 0. Okay? Okay, so let's move on. Okay, if you differentiate a slope like this, then you can get an answer. Okay, so for these ones, if you differentiate a cubic function, you will get a quadratic function. So if I differentiate this one now, if we differentiate this one, let's differentiate this one. You see we'll get a quadratic. See the solution. The quadratic is the differential function of the cubic function. Remember, this blue one is the cubic function, okay, the original function. So the quadratic is the solution. Okay, let's differentiate this one. dy over dx over ds, which is, you can write f prime of x. Okay, it's the same as dy over ds. Instead of writing dy over ds, sometimes you can write like this, f. If it's written as function of x, differentiate x, I'll get 1. So I'll get 4x plus 1. So that's what they got here. Okay, see, 4x plus 1. That's how they got this 4x plus 1. So first you have to divide the numerator and denominator by x to get this function. And then before you now differentiate this function to get this one. Blah, blah, y equals to 1 over 3x cubed minus 4x plus 5. Find the coordinates of the stationary point of the graph. You see, this question is in every Cambridge paper, this particular one, and the one I showed you before. These are the two ways with which it comes. Okay? They give you a function, they say find the coordinates. Find the coordinate of the stationary point of the graph. So you know what we do? We differentiate this, we equate to 0. So when we differentiate this, we get dy over ds equals to 3 times you get x. 3 multiplied by 1 over 3 is 1. So you get x raised to power 2 minus 4. X raised to power 2 minus 4. If you differentiate this function, this is what you will get. You equate to 0. Why we equate it to 0? You know, normally if it's not stationary point, they will give us the gradient. We say equal to 8 if they've given us the gradient. But this one, once you see stationary point, you should equate to 0. It's like turning point. These turning points I was showing to you. Okay? these are called stationary point. So stationary point. Stationary. So once you see stationary point, you equate to 0. So you go to equate this function to 0. Now you solve this quadratic. Okay, to solve the quadratic is easy, right? So it will be plus minus 2 because you move this 4 to this way. So x square equal to 4. Move 4 to this way. So if you take the square root of both sides, take square root of here, take square root of here. Square root, we cancel square to find the value of x. So once you take square root of a number, the answer will be what? Two answers. Plus, minus 2. Meaning there are two answers. X1 is plus 2, x2 is minus 2. You have two values. Okay? These two values, we're going to substitute it to the original function to find the two values of y. These two values, you know, this, if I write like this, I actually have two answers. Plus 2 and minus 2. These are my answers for x. You take them and put here. If you put plus 2 here, 2 squared is 8. 1 over 8, that means 8 over 3 minus 4 times 2, that's 8. 8 over 3 minus 8 plus 5. When you do that, you get negative 1 over 3. You get negative 1 over 3. Then you take the second value, minus 2. Remember, it's a quadratic. You must get two answers. Minus 2. If you bring minus 2 and substitute here, you get 10 1 over 3. So you now write the coordinate. Remember, they say find the coordinates of the stationary point. There are two coordinates. When x is plus 2, your y is minus 1 over 3. And when x is minus 2, your y is 10 1 over 3. So these are the two coordinate points. Okay, these are the two coordinate points. So that's why you see the word is coordinates. No coordinates. Coordinates. Two coordinates. One here, one here. Okay, there are two coordinates. Okay, this is another way the exam comes. Okay, I think once you understand this concept, it should be good to go. I've already explained second derivative. Second derivative is less than 0, then you have a maximum point. If it's greater than 0, you have a minimum point. You also need to keep this one in your mind. But I think they don't always exploit this one much in IGCSE. Maybe for A level higher, grade 12. When your second derivative is less than 0, you have maximum point. When it's greater than 0, you have a minimum point. Okay? So you pause and solve all of these questions. I think with this, we come to the end of our today's class. Thank you for joining us. Thank you. See you again in our next class.